Okay, welcome back to another episode of building a compiler in JavaScript. So last time, this is what we've got so far. So we started on the Lexer and we started on our sort of interpreter. So if you remember, we wrote this function which basically just reads from standard input and then saves it to input here. Oh crap. Added a couple of commands, very basic ones, and then Lex the input. So if we have a quick look at our Lexer, basically when we construct it, we've got these. So this is just the input list of tokens, which is empty, and then these are how we actually determine what tokens we want. So we match against a regex basically. The tokenize function just goes through basically the whole input text, goes through it character by character, and then goes through all of the token types. So this isn't very fast, but right now we're not too worried about how fast it is. We just want to get it working basically. So we try matching up to the current index. If there's nothing there, we'll just advance by one. If we match, then we basically append to tokens, we push to tokens, just an object basically. And then if we have any errors, we log it here, and then we just return tokens. So let's just go into the code again. Yeah, so you can see we've got the tokens here being printed correctly, which is good. First things first, I want to change this. So just having one type binary operator isn't really ideal. Also, let's move this in a bit. I think that might be a bit easier to see. And also I'm going to put this on a new branch. Oops. Let's call this episode to Parser. I think that's good. Okay, nice. So, looking good. So yeah, so we're changing the types. So we'll do type like this, and then regex like that, and we'll just copy paste this a few times. That's enough. So rather than just having one type for binary operators, we're going to have a type for all of them. So we'll have plus token, minus token, let's call this times token, and call this divide token. Cool, and then the regex for these will be pretty similar to ones we've already got. That looks good. So I'm going to copy this, change it to minus, star, and that should be good. Okay, looks nice. So let's just try running this again. So we're getting a plus token, let's do, and we're getting a minus token as well, so that looks good. Okay. So next thing I want to do is, as it stands, we've just sort of got this list of tokens, which is absolutely fine, but it might be quite useful down the line to add a sort of terminating token, so like an end of file token. So what we'll do is we'll do this dot tokens dot push, and we'll just push an end of token type. Sorry. We'll just call this end of file token, and just give it the token value, something like that. I think that should be okay. Okay, and let's try this again. Okay, didn't do that. Maybe this should be up here. Why are we not? Oh, I'm an idiot. No, this is right down here. Okay, so yeah, perfect. So just ignore what I'm doing now. I'll edit that out. So we're now terminating within the file token. Good. What we'll also do whilst we're here, we'll get rid of the white space tokens for now, just because they're taking up loads of space and it doesn't really matter. Don't need to worry about them yet. So let's just do. Let's do something like this. So basically, go through all the tokens. If this .tokens.token type is equal to white space, then we'll splice. We'll splice at this index, token index, and we'll just delete one token. So basically, go through the tokens. If we have a white space token, we just basically cut it out of the array, and this will just return a new array. So that looks good. Test it out. And yeah, perfect. Okay, looking good. Right, I don't think there's anything else. I'm going to add here actually, just do Lexer error, so because when we start writing our parser, don't want to get confused between them, so that looks fine. Okay. Cool, so now we've got let tokens equals lexer.tokenize, and then that's just returning that. So let's get rid of this console log. What we'll do, I think, if we do, add some debugging bits. So if we do let show tokens equals false, if show tokens, then we'll do console.log. Let's just do show console.log tokens, and then we'll add a command here, else if input, let's do tokens like that, and then we'll just do show tokens equals not show tokens. And then let's also print let's do displaying, showing tokens, hiding tokens. Okay. See what this does. What's it doing? Oh, we should probably continue. Might help. Tokens. Cool. Oh, tokens. Yeah, perfect. Alright, nice. So, what's next? Yeah, so we've got a list of tokens here. Now what we need to do is we need to pass these tokens. So if you remember from here, done this. Done. Now we need to do parser. So basically we need to write some code to go through this list of tokens and build out this abstract syntax tree. So if we've got this 1 plus 3, we're going to generate a tree that looks something like this. Oh god, drawing these is always so painful. Like that. So we need to generate some kind of structure that look like that, and that's what we're going to focus on this episode, even though we've already spent 10 minutes on trying to improve the Lexer. So anyway, right, let's do class parser, constructor. Let's do, how do we want to do this? We want to take in tokens. This dot tokens equals tokens. I think we're going to want to keep track of position. So when we go through the token list, we want to keep a track of what index we're at. So that's what we're going to do there. Okay, yeah, that looks good. Let's put this into new file. And what we're actually going to do is make these private. Just do these as private, so that way when we bit of JavaScript syntax for you, this putting a hashtag before any variables or methods makes it private. So if we create a parser here, and we try to do something like, oh, I don't know, tokens, then it will throw an error. So yeah, there you go. Let's get started. So how do we want to do this? I think probably the best way is to go and do, I think it's a recursive, oh, what's it called? Recursive descent. So this is what we want. So, thank you. So yeah, so this is what we want. We want a recursive descent compiler. Yeah, I don't really understand any of the stuff on this, but if you're interested, I'll chuck it in the description. But that's the type of compiler we're going to choose. It basically just reads in the tokens and then goes through them and then recursively creates a tree kind of structure that we can, once we've created it and we've verified that it's correct, we can do what's called walking the tree and evaluate. So that's the third step, analyze and calculate. So yeah. Right, how are we going to do this? So I think we're going to want a couple of helper functions. So we're going to make these private. So let's do current token. So this will just return current token. Return current token. Need to write a function for that. So let's just do that for now. We're going to want a function that in the future it might be useful for us to look ahead of the tokens. So call this, let's call it peak, and then peak will take in parameter called offset. And basically this function lets us look ahead of the current token, or gives us the current token if offset equals 0. So yeah, so what we're going to do is going to call this variable let index equal this dot position plus offset. I don't want to import that, thank you. This plus offset, and then if this index is greater than the length, actually should we do greater than or equal to the length, yeah, so if the index is greater than or equal to the length of the tokens array, then we'll just return the last token. this dot tokens, this should be hashtag, and this dot tokens dot length -1, and then otherwise we'll return this dot tokens index. Okay, so now we can use this function in here. So we'll just return this peak 0, and that looks good so far. Right. So we're going to want another helper function. We'll call this one match. So this will match match a kind of. So we'll give it a kind, and we'll match. Try to match against the token. So let's do if this dot current token dot token type. Let's call this type. Actually, that's better. Equals type. Then we'll return. Basically, we want to return this token and advance it forward 1. So we need to write a function for that as well. Then otherwise, we'll throw an error, or throw an error in air quotes. We'll call this parser error, bad token, and we'll just say bad token type. Let's put these in backticks actually. So what do we got? Oh, we got this dot current token dot token type. Oops, and then let's say expected type. Okay, and just return. Yeah, that looks good. So we need this function here to return the current token and advance the next token. So let's write that as well. Just call it next token. So we'll let current equal this dot current token. We'll do this dot position plus plus. So just increase position by 1, and then we'll return current. So all this function does is returns the current token, increases the position of 1. And then let's fix this. So we need to return next token like that. Okay, looks alright. So we've got our helper function sorted. Right, now we want a public function just called parse. And this will just step through the token list and start to form our syntax tree. So for now, obviously the only types we've got are these, just very basic mathematical operations. We're just going to focus on plus and minus for now. So plus, minus, to be fair, times and divide also. These are all binary operations. So that's what we're just going to start by handling. So first thing we want to do is we want to match a number token, because once we know there's a number token there, then we can look ahead and see if the next token's an operator, and if it's not, then we can throw an error. So let's do that. So this will be, let's just call this left, and then we're going to need to create a helper function for this. So if we do, to be fair, I don't know if we need, let's just do this dot match. Actually no, I'll put it into a function because we might use this quite a bit. So let's just call this parse binary expression like this, and all this does is returns not return, returns this match, and we just want to match it with a number token, so just number like that. So we'll do let left equal parse binary expression, and then that's good. So then now, what's this actually going to do? So parse binary expression does this match number. So if it matches a number, then it will return. Where is it? It will return the current token, so it will return the number token, and then it'll advance the position by 1. So then what we can think is the next token should be a plus or a minus or a star, something like that. So if we chuck a while loop in, token type, let's do plus token, and then we'll do an or, that's not an or, like that. Minus token, like that. Cool. So while that's true, then God, what's going on with my brackets today? That's not supposed to. Oh my gosh, that's not supposed to be there. Okay, so while that's true, the operator is going to be the next token. So we'll let operator token equal this dot next token. So again, we're returning the current token and advancing by 1. So far we've got is left. Left. If we're using 1 plus 2 plus minus 3 as an example, then the first thing it matches is a number. So then it's incrementing a position. So the current token is that, and then that becomes our operator token. So then we're calling this to return the operator token, and then we're advancing it by 1 again. So then we've got this. Cool. And then we'll do let right equal, I think I'm going to call these left token and call these this one right token, just because I might get a bit confused otherwise. And then for right token we want to call parse binary expression again, because we want to find another number token, because otherwise if we get like another plus, then it's not what we want, and then that'll throw an error. So now if we want to sort of do this recursively. So if we've already assigned left token up here. What we want to do is we want to append to left token everything we've got so far. So what we'll do is we'll create a new object, and this object will be our tree. So we'll call left is left token. So basically what we're doing is taking this value, putting it into here, and then reassigning left token, so that then when we come back up here, we can repeat the process again and handle more like unlimited operations basically. So yeah, so what we've got so far, if we think about what we've got, so we've got left will give us this, and then we advance, so then we get operator token which will give us this, and then that'll advance, and then we get this which will match a number. And then now if we finish this off, so operator token and then right token, so that's our object, and then basically we're chucking all this back down to here and then repeating the process. So then we'll have, so this will all be the left, and then we'll go to right. So hopefully that makes sense. Once we start printing out, it should make a bit more sense, but for now we'll just continue. So that looks like everything, and then we just want to return left token, which will sort of be like our abstract syntax tree. So this looks okay. So far I can't see any glaring bugs. Let's just give it a go. Might need to import it. And then if I'm missing semicolons, don't worry, I'll lint it all afterwards. I can't bother to do it right now. So let parser equal new parser with tokens, and then we'll do let ast equal parser, parser.parse. What is that? Has it imported something? Okay, that looks fine. And then we'll just console log ast. Fine. Okay, looks good. Let's oh, no errors, that's a good sign. Okay. Oh, no, I do this. Okay, that looks good. Right, so ignoring my stupid export bug, because I'm an idiot, we can have a look at what we've got here. So we've got, actually, let's also show tokens as well. And we'll make this a bit bigger so we can see everything. So, got our tokens, all good. And this is our abstract syntax tree now. So, we've got a left operator and a right. So, this left is an object as well, and it's got left operator and right as well, with 1 plus 2 in it. And then we've also got our -3. So if we, where was it? If we go back to here, so what we're inputting is 1 plus 2 minus 3. Basically what our tree is going to look like is something like this. Want something like this. And that's basically what we've created. So that's messed everything up. But yeah, so that's basically what we've created, but in like an object, in an object form within JavaScript. So this is like the left node of the tree, and we've got 1 plus 2, and then this is our right node. So yeah, so it looks good. Well, it looks correct for now, which is important. So one thing I want to do as well is if we start doing something like something big, we start getting this, which isn't very helpful. We're going to write a quick function called print ast. And I'm not going to lie, I might just copy this from ChatGPT because I can't be bothered to write a function like, not a function, yeah, exactly, a function like this. So I'm going to copy and paste this. Yeah, I'm just really quick at coding, basically. Yeah, no, so if you, this, I'm going to zoom out a bit for this. This is just a function that takes in the tree and then has all these sort of initial parameters, and all it does is prints out the tree. So if you've ever used like Unix before, like Linux, sorry, and you do the tree command, this sort of prints out similar to that. So what we're going to do is pretty print tree. And we're just going to log that to console. So let's try this again. Okay. Oh, it's that's the problem with TypeScript. Actually, let me do it like this. Oh, okay. I'll do this. That might work now. Let's try it. Okay, there we go, perfect. Yeah, so print it out in a nice little tree sort of diagram, and if we make it, I don't know why I X'd it, we can make it as complicated or as simple as we like, and it will just keep going recursively. Okay, so I think I've been chatting on for bloody ages now. What I think I'll do is let me lint this all first. Oh, okay, fine. Looks a bit nicer now. Let's. Okay, fine. Cool. Alright, well, thanks for watching. In the next episode, we'll start to improve our Lexer a bit. We'll start taking in some strings and keywords and stuff like that, and we'll also create an evaluator class, so that once we've created this syntax tree, we can step through it and we can actually evaluate what this will equal. So, yeah. Thanks for watching, and see you next time.